One of the most profound scientific laws is the first law of thermodynamics. The first law helps us to understand scientific phenomena carried out on a day-to-day basis, while also keeping our world in a controlled state rather than outbreaking to chaos. The first law has some interesting applications, but first, how exactly does this law work? The first law of thermodynamics describes that energy cannot be created or destroyed in an isolated system, and that the total amount of energy in an isolated system must remain constant because of this law of energy conservation. In the realm of thermodynamics, there is a special and isolated place during experimentation known as the system. The system is the place or thing that is changing because of the release or exertion of energy done to or from it. The system can be a chemical solution or an atom. Everything else that is not the system are the surroundings, which can include the flask of the chemical solution or the space surrounding the atom. The system is the basis for understanding how energy is put into and how it is taken out of the system. Energy can come in the form of work and/or heat. In other words, when energy is put into or out of the system, energy can either make the volume of the system bigger or smaller, or cause movement, which is a change in work, and energy can raise or lower the temperature in the system, which is a change in heat. Work and heat are the fundamental concepts of understanding energy flow in a system. An important concept to understand is that energy flow of a system can be endothermic or exothermic. Endo meaning energy is put into the system, and exo meaning energy is put out of the system. From these key words and the equation, we can then infer that energy in a given system must be equal but opposite in sign to its surroundings, because energy is not created or destroyed. We can also infer that if the overall change in heat or work of the system is positive, endothermic, then the overall change in heat or work of the surroundings must be negative, exothermic. However, if this is the case, we say that the overall change in energy is positive or endothermic because we are referring to the system. This change in energy is always being transformed from the system to the surroundings and vice versa. Energy is not being created or destroyed, but rather transformed and carried. In photosynthesis, energy goes through a process to convert light to chemical energy and can also be converted to heat at the end of the Calvin cycle, known as non-photochemical quenching, which means that some of excess energy absorbed by chlorophyll can be dissipated as heat, reducing the temperature of the plant so that it can stay cool in summer months. Similar applications of the first law include knowing the heat needed to create a reaction we desire, understand concepts such as the Big Bang, knowing the heat needed for a photon to increase or decrease from energy levels within an atom, or even knowing the heat needed for an egg to fully cook on a frying pan. I hope you enjoyed this video. Thanks for watching, and I'll see you in the next one.